All right, we just saw in our last video that if we can't factor, we can still solve a quadratic equation if we can take and make the left side, the x squared, and the x term into a perfect square, meaning factors that are the exact same thing. And instead of writing them twice, we can write it as that quantity squared and then use our square root to solve it, right? Well, look at the quadratic equation x squared plus 6x plus 4 equals 0. If you tried to factor it, there are no numbers that multiply to 4 that add to give us positive 6. So we wouldn't be able to solve it the normal way by factoring. So let's see if we can use that trick that we did in the last video to try to make this into a perfect square so we can use our square root technique instead. So here's what we're going to do. We're going to take that 4 and we're going to move it over to the right side of the equation so that we can just work with the x squared and the x term. When I move it over, I'm going to subtract it over. I'm going to leave a little bit of a space there because what I want to do is I want to figure out what number I can add to this side to make it into a perfect square so I can factor it and write it as the quantity squared. And I'm allowed to do that as long as I make sure, remember, that I add it to the other side to keep that equation balanced. So what number can I put at the end of this left side so that when I factor it, it becomes a perfect square? We need numbers that multiply to this blank number here, that when I add them together I get 6, but they're the same exact number. Well, did you say 9? What if I add 9 to both sides? My equation is still true and is still balanced as long as I add 9 to both sides. And now look at the left side. I can factor that into a perfect square. Numbers that multiply to 9 that also add to 6 are 3 and 3. I can say x plus 3 and then times an x plus 3. Or, because they're the same exact thing twice, I can really say x plus 3 squared. You notice on the right side that I can take the negative 4 plus the 9 and really combine those like terms and say equal to 5. Now look, now I can take my equation, I can square root both sides, and then I can finish solving this quadratic even though I wasn't able to factor it. This is a technique called completing the square. You should be able to factor. If you can't factor, you should always be able to solve a quadratic using completing the square. Let's do a few practice problems. Now before we actually get into completing the square from start to finish, let's just practice that piece where we have to figure out what number to add to both sides. We actually can figure out how to complete the square, it's called, by taking the x squared and then the x term, whatever bx is, and we can find the number to add to both sides by taking the b, the coefficient in front of the x, dividing it by 2, and then squaring it. Go back and look at this one. If I were to take that 6, divide it by 2, 6 divided by 2 is 3, and then taking that 3 and squaring it, I end up getting 9. So then I know that 9 is the number that I want to add to both sides in order to complete the square. Let's do a few practice ones of that. In example number 7, it asks us to fill in the blanks so that we can complete the square. So if I have an x squared plus 14x, what do I need to add to it so that it is a perfect square when I factor it? I want the same factor twice. Well, if we use the trick that we can take the number in front of x, in this case the 14, divide it by 2, what's 14 divided by 2? 7, and then take that 7 and square it. Well, 7 squared is 49. So 49 is the number that I'm adding to both sides. When I do that, and I end up factoring it, this factors into an x plus 7 times an x plus 7, or I can say an x plus 7 squared. Let's look at B. This one's a little bit harder because I need to figure out what number would end up giving me a perfect square factor. Well, let's use our trick. If I take the number in front of x, which in this case is a negative 5, and I divide it by 2, I end up getting a fraction or a decimal. That's okay. Let's go ahead and stay away from decimals, but let's use fractions. We can still use fractions. They're still numbers and they still work, right? You might not like them, but they still work. Let's take that negative 5. Let's divide it by 2. So negative 5 halves. And then let's square that number. Well, squaring means I'm multiplying it by himself, right? So negative 5 over 2 times negative 5 over 2 is really positive 25 over 4. That's the number that I'm going to add to both sides if I were doing the process of completing the square. So when I go to factor this side, numbers that multiply to 25 over 4 that add together to give me negative 5. Ooh, that one's kind of a hard one. It ends up being x minus 5 halves. Now, that 5 halves looks familiar, doesn't it to you? Well, if you notice, the 5 halves is actually the number that I got when I divided by 2. And 7 is the number that I got when I divided 14 by 2. Do you see that little trick? And 3 was the number I got when I divided 6 by 2. So that kind of helps us when we're going to factor also. It's a little trick that we can use to figure out what the factors are. So try the next one. If I have x squared plus 3/4 x plus, what would that blank have to be so that when I go to factor it, it ends up being a perfect square? Well, let's use our trick. That I can find that number by taking the number in front of x, that's the 3/4, dividing it by 2. Ew, we don't want to do that, right? Instead of dividing by 2, couldn't I really multiply by the reciprocal, 1 over 2? And so when I divide it by 2, I really get 3 over 8, right? But then I want to make sure that I take that number and square it. And that's the number that I'm going to add to both sides. 3 over 8 squared is really 9 over 64. Now, I need you to factor it. What numbers multiply to 9 over 64 that when you add them together, you get 3/4? Well, if you remember the trick, it's always the number that we get when we divided by 2. So you should end up getting 3/8. It multiplies to 9 over 64, and if you were to add it together and reduce, you end up getting 3/4. So this is the part where we need to focus on when we're going to complete the square. We're going to add to this here in the next video to do the whole entire process from start to finish so that we can solve a quadratic equation that may not factor.